Section 8.2 is all about the sampling distribution for the sample proportion. In 8.1, we looked at the sampling distribution of the sample mean. For the proportion, it's a little bit different, and the calculations are a little bit more challenging, so we have to be very careful with the way that we're doing the calculations. Now, the proportion we can think of as like real similar to the relative frequency, and it's also related to the binomial distribution. So you'll see some of these formulas, they kind of look similar to what's in that binomial distribution. And there's also another direct connection once we get to the conditions that I'll point out to that binomial distribution. So I have here just the general properties of the sampling distribution, and it's based on binomial trials. R is the number of successes, P is that probability of success. And if we're looking at the sampling distribution, the mean of it is equal to the probability of success, that P. The standard deviation of it is equal to this here. So a big square root, and then within there, P times 1 minus P divided by N. So it still has that adjustment of this division by the square root of N that we saw in the sampling distribution of the sample mean. Now, the conditions, or the thing that makes it into a normal distribution, is different, and it depends on the value of not only N, but also P. So the rule of thumb that we'll use for the sample proportion is right here. This N times P times 1 minus P is greater than or equal to 10. This is the normal criteria, which is similar to the N is greater than or equal to 30 that we saw in the sampling distribution for the mean. Okay, now I have these conditions down here. Random sampling is the same, and the independent sampling also the same as what we saw from the mean, but this normal criteria here is different. We check the rule of thumb, N times P times 1 minus P is greater than or equal to 10. Now, you may see other rules of thumb that people use. It's not fully agreed upon within the realm of statistics. For the book that we're using, though, we're going to use this rule of thumb, that N times P times 1 minus P is greater than or equal to 10. I actually do like this rule of thumb, because if this one is true, then the other one that's very commonly used is automatically true. The N times P is greater than or equal to 5, and N times 1 minus P is greater than or equal to 5. But this class used this rule of thumb. Okay, now one other thing with this normal criterion, if this isn't met, if that criteria is not met, then we have to use the binomial distribution instead. So you'd have to go back to that stuff that we did in chapter 6, I think it was. In chapter 6, the binomial distribution, you'd have to use that distribution if that N times P times 1 minus P is not greater than or equal to 10. Okay, so here's an example, and these I find are trickier than the 8.1, the ones with the mean, because they sometimes give you it worded in a way that's not exactly a proportion, so you have to first make a proportion. So what this says is the annual crime rate in Capitol Hill neighborhood of Denver is 111 victims per 1,000 residents, and this means that 111 out of 1,000 residents have been the victim of at least one crime in the past year. So yeah, annually. This neighborhood has a population of about 17,000. And what is the population probability P that a resident of the Capitol Hill neighborhood will be the victim of a crime this next year? We can use that crime rate that they're giving, which is 111 out of 1,000. And that gives us 0.111. That would be, in this case, probability of success, quote unquote, that they would be a victim, 0.111. And now this one says the Arms is an apartment complex in this neighborhood that has 50 residents. Suppose we view each of the 50 residents as a binomial trial. And with the binomial trial, if we make that assumption, that gives us both random sampling and independent sampling. You definitely could argue against those, especially since they're in the same apartment complex. Probably not independent sampling because they're in the same place. So if one crime happens, they're in proximity to it. So it may be like, I always think of like a spree of burglaries in the same apartment complex. Maybe they hit more than just one complex or one apartment in that same complex. Anyway, we're just going to make that assumption and move on to another check, which would be for the normal criteria. And in this case, N is 50 because there's 50 residents, and we're looking at them each as a trial. So it's asking, can we approximate P with the normal distribution? The wording of that, we're looking at the N times P times 1 minus P, which in this case is the 50, which we get from here. That's N times P, which we calculated part A, 0.111, times 1 minus 0.111. And this gives us, actually I can put exactly what it gives us, which is 4.93395. This is not bigger than 10, so we can say no. This is not large enough. Since it's not greater than 10. In this case, just to put another note, in this case, you have to use the binomial distribution. Have to use a binomial distribution. Okay, now another apartment complex has 200 residents. It's asking the same exact question. We're really doing nearly the same thing, except we're switching that number. So wait, let me take this. And change this to 200. Since there's 200 people, residents here. Do that multiplication. And in this case, it gives us 19.7358. And because of that, this is bigger than 10, which is good. So let me write that here. So yes, this is larger than 10. So we can approximate with a normal distribution. Okay, now what are the mean and standard deviation for this distribution? So this is referring to part C, not to part B. We can use the formulas from above, so just to remind you, P is the mean, and then this square root of P times 1 minus P all over N is the standard deviation. So I'm going to write this in the symbols that I had up there. This is equal to P, which is 0.111, and the standard deviation is the 0.111 times 1 minus 0.111 divided by square root of, or just n, 200, which is all inside a square root. Now this is sometimes difficult to plug in because you have to be very careful with the parentheses. So you definitely want to make sure you can get this. I'll show you how to do this on Excel in just a couple seconds, but you should be getting that answer there for that calculation. It's very often students will forget these parentheses, so just be careful with that. And then also make sure this 200 is within the square root. Don't do it outside of the square root. So just be careful with that as well. Those are the two most common mistakes with that calculation. Okay, now it says using this normal distribution, what's the probability that more than 10 people will be the victim of a crime next year? Now this is kind of the part where it gets really tricky because 10 is not a proportion. 10 is not from 0 to 1, and so it's not a proportion, so you have to be very careful. It's actually describing R, which is 10, over N, which is 200. So we do 10 divided by 200, which gives us 0.05. So I'll write also in symbols here the probability of P hat being greater than 0.05. That's giving us our lower limit. And at this point, we can go to our Excel file in order to get the calculation of this probability. Okay, so here we're doing a right tail test. And the mean is 0.111. Standard deviation is this one that we have to plug in. So I'm going to tell you what I'm typing here. So it's the square root SQRT, which you have an equals before that, 0.111 times another left parentheses, 1 minus 0.111, right parentheses, a / for division, type 200, and then close the parentheses. I'll let that there for just a couple seconds. Press enter. If it throws you an error, you might need to go back, press OK, and then go back and check to see if you typed it correctly. Lower limit in this case is 0.05. Press enter, and it gives us this probability, which is pretty high. Okay, so I copied that down. Let me show you what I wrote down.